Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Yusra Nadatul Alyeea Binti Yusramizal. Now I will be presenting about option 2, Deep Learning, Image and Bioinformatics. So the research paper that I choose entitled Deep Learning in Image Classification Using Residual Network, ResNet Variants for Detection of Colorectal Cancer. Okay, so for the first part is source provided from the article. This article or research paper entitled Deep Learning in Image Classification Using Residual Network, ResNet Variants for Detection of Colorectal Cancer. There are a few authors for this research paper, which are Darvi Sarwinda, Rahmat Hidayat Paradisa, Ahmad Bustamam, Pratiknya Anggia. And the publication venue is Procedia Computer Science, 5th International Conference on Computer Science and Computational Intelligence 2020. The publication year of this research paper is in the year of 2021. Okay, so this is the idea of the research paper, which is to evaluate the effectiveness of ResNet, or the long name is residual network, variants in classifying colorectal cancer images. So basically, this research paper is about using ResNet in classifying colorectal cancer images. So the dataset that they use is colorectal cancer images. The innovation used in this research is advanced deep learning techniques to improve medical image classification accuracy. So basically, they want to improve the accuracy of the image classification. In this research is about colorectal cancer image. This is about the input data of this research paper. The type of data used is colorectal gland images from Warwick QU dataset. This dataset consists of 165 images, 74 benign and 91 malignant. The resolution of the image ranges from 467 times 430 to 775 times 422 pixels, and it is scanned by using this Mirax MIDI scanner. This is the process of this research. So for the first part is data preprocessing, where the first part is to convert images to grayscale. Secondly, to enhance contrast by using contrast-limited adaptive histogram equalization, CLAHE. And then resize images to 224 times 224 pixels. The second part is feature learning and classification layer, where they use residual network 18 and residual network 50 as the model for feature learning layer and also classification layer. And the last part is training, where they use optimization algorithm, which is stochastic gradient descent with momentum. This is the research flow, the diagram of the research flow, how we do preprocessing and then learning model and what performance evaluation. So as you can see here, the data set consists of colorectal cancer images, which is divided into two, benign and malignant. This is the difference between benign and malignant. Okay, and then second part is we will do data preprocessing, where, as mentioned before, they will cover images to grayscale, and then they will enhance contrast by using contrast limited adaptive histogram equalization, CLAHE, and then resize images to 224 times 224 pixels. And then in learning model, they will use residual network 18 and residual network 50 for both feature learning layer and also classification layer. And for the last part is performance evaluation by using a few performance metrics. In this research paper, they use accuracy, sensitivity, and specificity. So basically, this is the ResNet architecture that consists of, as you can see here, there are 5 layers here. First convolutional layer, and then second convolutional layer, third, fourth, and fifth. Okay, and then they will train to several layers here, 18, 34, 50, 101, 152 layer. And then for the last part, they will do floats, floating point operation. Okay. And then, okay, this is the output of the research, what they gain in performing the model. So for the ResNet 50 and also the ResNet 18, as you can see, there are differences between these two. You can see that the accuracy, sensitivity, and specificity of ResNet 50 is much greater than ResNet 18. As you can see, for the accuracy is 82.3% for ResNet 50 compared to 76.5% in ResNet 18. For the sensitivity also, ResNet 50 is much higher than ResNet 18, from 87.2%, and then compared to 80.1% for ResNet 18. And then same as specificity, where the ResNet 50 is slightly higher than ResNet 18, where ResNet 50 is 83.5%, and ResNet 18 is 78.4%. As you can see, the overall performance, ResNet 50 outperformed ResNet 18 in terms of all performance metrics, accuracy, sensitivity, and specificity. Okay, so this is the justification of this research. It is rooted in the high prevalence of colorectal cancer and the critical need for accurate diagnostic tools. Traditional histopathological examinations are often subjective and can vary among pathologies, leading to inconsistent diagnosis. Implementing a reliable deep learning model like ResNet 50, Residual Network 50, can provide consistent and objective diagnosis, thereby improving early detection and treatment outcomes for colorectal cancer patients. So as you can see, when the performance metric is getting improved, is getting higher than before, this will help in improving early detection of cancer classification. So it will help in detecting the cancer patients earlier. I think that's all from me. This is the reference paper that I refer in doing this presentation. Thank you.